Hi, my name is Dave Gill and I work for STEM Learning. Today we're going to talk about artificial intelligence and a particular type of artificial intelligence called convolutional neural networks, or CNNs. Have you ever wondered how computers can recognise images just like we do? Well, CNNs are the super smart algorithms that make it possible. CNNs are a type of artificial intelligence that can recognise and classify images. They're used in many real-world applications, such as self-driving cars, facial recognition software, and in this example, determining whether a windscreen can be repaired or needs replacing. Before we dive into convolutional neural networks, let's talk about neural networks. A neural network is a computer system modelled after the human brain. Just like our brain, a neural network has billions of tiny parts called neurons. These neurons work together to solve problems. But these neurons are not real physical cells like in our brain. They are virtual, computer-based units that mimic how a brain works. The power of a neural network is that it can learn from examples, recognise patterns, and make predictions just like our own brain. The power of a neural network is that it can learn from examples, recognise patterns, and make predictions just like our own brain. So the next time you talk to Alexa, or use a voice-powered device, remember that behind the scenes there's a smart neural network at work, helping it understand and respond to your voice. Convolutional neural networks are a special type of neural network designed to recognise images. They process images through different layers, each serving a very specific purpose. In this diagram, the input on the left is the image we are attempting to classify. The layers are split into feature extraction and classification. The first layer in a CNN is the convolutional layer. Imagine you're an art detective and your mission is to find important shapes and patterns in pictures. Now let's say we have an image of a cat. The convolutional layer works like a special filter that slides over the image, just like a magnifying glass moving across a page. As it slides, it looks for important features like edges, curves, or colours. Imagine you have a small piece of glass that you place on different parts of the image. You carefully observe what you see through that glass. If you find something interesting, like a cat's ear or a tail, you make a note of it. The convolutional layer uses multiple filters, each one searching for different things, just like having different detectives searching for different clues. Some detectives might focus on finding ears, while others might be experts at spotting whiskers or paws. As these filters slide over the image, they pick up these important features and create a new image with only those features highlighted. It's like a secret message that becomes more visible as you decipher it. The beauty is that these filters learn by seeing many examples. They can become better and better at recognising different features, just like detectives who get more skilled over time. So, the convolutional layer helps our neural network break down the image into those important pieces, capturing the unique characteristics that make a cat look like a cat or a dog look like a dog. Think of the convolutional layer as a team of art detectives with their special filters, sliding over the image, finding interesting details, and helping the neural network understand and identify what's in the picture. Next, let's talk about the pooling layer, which is like a detective that helps our neural network make sense of the images. Just like detectives look for important clues to solve a crime, the pooling layer looks for important features in our images. Imagine we're looking at the same picture from the previous layer. The pooling layer zooms in on different parts of the picture, but this time it checks each small area to see if something important stands out, like a shape, a colour, or a pattern. But here's the trick. The pooling layer doesn't keep all the details. Instead, it summarises what it sees and keeps only the most important information. It's like if we were describing a friend's face to someone. We might say they have blue eyes and curly hair, but we don't need to mention every tiny detail. By summarising the important parts, the pooling layer helps make the image smaller and easier to handle. It's like organising a big puzzle. If we have too many pieces, it becomes overwhelming. But if we group them together based on their shapes, it becomes more manageable. So the pooling layer helps our neural network focus on the essential features of an image and makes it easier for the network to understand and classify what it's seeing. In simple terms, think of the pooling layer as the detective that zooms in on the important details in the image and summarises them, make it easier for our neural network to recognise and understand what's going on. Now let's talk about the fully connected layer, which is like the brain's decision-making centre in our neural network. Imagine you're a detective who has collected all the important clues from the previous layers. You have a bunch of evidence, like the shape of the cat's ears, the colour of its fur, and the length of its tail. The fully connected layer is like your detective headquarters. It takes all those pieces of evidence and decides what they mean. It's like connecting the dots to solve a puzzle. In this layer, each piece of evidence, like the shape of the ears or the colour of the fur, is represented by a detective, or a neuron. Each detective focuses on a specific detail and tries to make sense of it. Now, these detectives talk to each other, sharing the information they have. They discuss the clues they found and figure out the most likely answer to the mystery. Is it a cat? Is it a dog? Or maybe something else? Each detective, or neuron, communicates with all the other detectives in the fully connected layer, passing on their findings. They combine all the information they have gathered to make a final decision about what they think the image represents. It's like a team of detectives working together, sharing their insights and opinions to come up with a unanimous verdict. They analyse the evidence from different angles and vote on the most likely answer. So, the fully connected layer takes all the important clues and evidence from the previous layers, puts them together and makes that final decision. Is this a cat, a dog, or is it something else? Think of the fully connected layer as the detective headquarters, where all the detectives gather, share their findings, and make the ultimate decision about what the image represents. Okay, let's talk about training our convolutional neural network, CNN, which is like teaching a brain to recognise things by showing it lots of examples. Imagine you're a music student, learning to play a new instrument. At first, you might hit the wrong notes or struggle to play a melody correctly. But with practice and guidance, you start to improve. Similarly, our CNN needs practice to get better at recognising images. We start by feeding it a large data set of images, like pictures of cats and dogs. The CNN looks at each image and tries to guess whether it's a cat or a dog. At first, you might not do so well, just like a beginner musician. But here's the cool part. The CNN learns from its mistakes. It gets feedback on its guesses, just like a teacher correcting your music performance. If the CNN makes a mistake and thinks a cat is a dog, it adjusts its thought process to improve the accuracy next time. This adjustment process is called backpropagation. It's like taking a step back and analysing what went wrong. The CNN looks at the difference between its guess and the correct answer, and then it updates its internal settings, like turning some knobs, to make better predictions in the future. Over time, as the CNN sees more and more examples, it becomes more experienced and skilled at recognising images. It learns to pick up on the important features, like the shape of the ears or the colour of the fur, that help it identify whether it's looking at a cat or a dog. Think of training a CNN like training a musician. You practice playing the instrument, get feedback to correct your mistakes, and gradually improve your skills. Similarly, the CNN learns from its training data, receives feedback to fine-tune its performance, and becomes better at recognising images. So training a CNN involves showing it many examples, giving it feedback on its guesses, and allowing it to adjust its internal settings to improve its accuracy. It's like teaching a brain to see and understand the world better. So let's explore how a CNN can help determine whether a windscreen can be repaired or needs to be replaced. Imagine you're helping a car mechanic who has to decide what to do when a windscreen gets damaged. Now think of the CNN as your helpful assistant in this situation. It's like a smart friend who knows a lot about windscreen damage. When a damaged windscreen is brought to the mechanic, they take a picture of it. The CNN steps in and analyses that picture, just like a detective examining evidence. It looks for specific things, like the size and shape of cracks, or the location of the damage on the windscreen. Using its knowledge and experience, the CNN compares the damage in the picture with a large database of other windscreen examples that it has seen before. It's like looking at a catalogue of different windscreen conditions. By doing this comparison, the CNN can quickly tell the mechanic whether the windscreen can be repaired or if it needs to be replaced. It's like having an expert advice right at your fingertips, just when you need it. This helps the mechanic make an informed decision and saves time and money. Instead of spending hours trying to figure out the best course of action, they can rely on the CNN's analysis. Think of the CNN as your wise assistant, examining the windscreen pictures and giving the mechanic a clear recommendation. Can I repair this, or do I need to replace it? It's like having a handy tool that helps make the right decision faster. Have a look at the images on this slide. Why do you think they all have kinds on them? Which ones do you think need to have the windscreen replaced? I'm just going to leave that there for a while so you can actually decide. Because the photos can be taken from different distances from the windscreen, the CNN needs a way of measuring how big the damage is. So the same sized coin is used as a comparison in all of the photos. If you were wondering as well which windscreen damage could be repaired and which could be replaced, the 3 images on the left were repairs and the 2 on the right had to be replaced. So, in real life, a CNN can be used to analyse pictures of damaged windscreens and provide guidance to mechanics, making it easier to determine if a repair is possible or if a replacement is needed. So, that's a glimpse into the amazing world of convolutional neural networks, CNNs. We've seen how CNNs work like detectives, breaking down images into important clues. They zoom in on details, make decisions in their detective headquarters, and even learn from their mistakes. CNNs are not just cool technology, they have practical applications too. For example, they can help mechanics decide whether a windscreen can be repaired or needs to be replaced. By analysing pictures of damaged windscreens, they become our helpful assistants, providing expert guidance. Just like detectives and musicians who practice to improve, CNNs also need training. They learn from examples, receive feedback, and adjust their thought process to become better at recognising images over time. The world of AI and CNNs is full of possibilities. From self-driving cars to facial recognition, these technologies are changing the way we live and interact with technology. So next time you see a damaged windscreen or use a cool app that recognises your face, remember that behind the scenes there's a clever CNN at work. Keep exploring the exciting world of AI, and who knows, maybe you'll be the one to come up with the next groundbreaking idea that makes the world a better place. Thanks for joining us in this adventure into the world of convolutional neural networks. Stay curious, keep learning, and embrace the possibilities of AI.